So this is an exciting problem. It shows us how we can use some of the things we've been learning about. So it says an airplane's flying at an airspeed of 200 miles per hour. Okay, so that's a magnitude of a vector. The airplane's headed on a southeast bearing of 140 degrees. So we'll talk about bearing in a minute when we go to draw this. A north wind from north to south is blowing at 16.2 miles per hour. So there's a wind, and that's going to be a vector as well, and it has a magnitude of 16.2. We'll talk about the direction in a minute. Now they want us to know they want us to find the ground speed and actual bearing of the plane. Okay, so there's a picture in the book. You can look at that. So sometimes they provide you with a picture. Sometimes you have to draw your own picture. So I'm going to draw a north. Okay, now bearings, that's like a whole nother topic when we talk about the bearing of a plane or a boat or something like that. So this bearing is going from the north, and it's going in a southeast direction. So it's coming down this way. Southeast would be this direction. Okay, and that's the plane. Well, you'll just have to use your imagination how the plane's going. The plane's going this direction. Well, it's actually going this direction, right? Okay, forget drawing the plane. Let me just erase that. My diagram of a plane. Anyway, that's the plane. I'll put plane. Okay, and we know the direction then of this plane. We know that this is 140 degrees. Okay, so that's how it heads out. You know, it's heading out in that direction. And if there were no wind, it would stay in that direction. Okay. We also know the magnitude of this vector. I'm going to call it vector V. And so the magnitude of that vector is 200 miles per hour. Okay. There's another vector from the wind. Now the wind is blowing from the north to the south. So I'm going to draw it from the north to the south. Okay? So this is going to be the wind. It's going directly south. Okay, so it doesn't have anything else on that. And it's going 16.2 miles per hour. So that would be the magnitude of the wind. So we'll go wind, and the magnitude is 16.2. Now, think about picking up that little orange vector and adding it to the plane's vector. Okay, I probably drew it a little bit too big. Okay. That gives us then, because remember we add vectors tip to tail. Okay, so there's my plane, but it's being influenced by this wind that's blowing it a little bit off course and probably slowing it down a little bit. Okay, maybe it's not. Maybe it's helping it speed up. That is the resultant vector. Okay, that's what we are interested in finding then. We're interested in finding the magnitude of it and the actual degree bearing here. Okay, so this would be our theta. Okay. Okay, so I kind of spaced out like what to name this. Anyway, we'll just call this vector x, which I don't really like that, but okay. There is a little triangle here. I'm not sure what you want to see as a triangle, but it's that green line, the orange line, and the black line. It's not a right triangle. It's just a triangle, okay? So we're going to go back to some things that we know about triangles. Okay, we know this angle right here, we'll call it alpha, that angle right there is important to us, okay? And then we're going to need, we know the magnitude of the orange leg and the black leg. And so what we want to do is we want to know we want to know the length of x, so the magnitude of x. So we can say that the magnitude of x is equal to, and then I have to think a little bit about how to get that angle. We don't have any angles right now. If I draw, let's see, Okay, so if I draw, this is a little hard to visualize, so I'm going to try to put it in a different color here. But think of this being like this vertical line here, okay? And then having another vertical line right here. Those lines are parallel, okay? And so the vector of the plane is bisecting those parallel lines. And so we have what's called opposite interior angles from geometry. And so it means this angle right here is 140 degrees. Now, that's going to allow us enough information to find x, the magnitude of x, okay? And to do that, we're going to use the law of cosines. Okay, so law of cosines, let's go back to that for a minute. So how do I want to label it? Well, c squared is equal to a squared plus b squared minus 2ab cosine c. Okay, so the angle that we know is the 140. The thing that we're trying to find is x, so let me write this out. So the magnitude of x is going to equal, and then we know the a and the b, the 200 squared plus the 16.2 squared minus 2 times 200 times 16.2 times the cosine of 140 degrees. Okay, so I'm going to have to put that all in my calculator. Oh, this is squared, by the way. So if I want to find the magnitude of it, I'll have to take the square root of whatever that stuff is. So I'll write it out for you here, but I'm going to stop the video to put it in my calculator. It's going to take a while. But you can also do that. Make sure you're in degrees. Okay, and also you're going to have to make sure you put in parentheses. So you know a set of parentheses is going to open here. You're going to want, let's see, that's okay. You're going to want a parenthesis here and a parenthesis there, okay? And then that should work for you. So I'm going to stop this and find that number. So it took me a while to put that all in the calculator. Anyway, now we're getting the magnitude of x to be about 212.665, which is about 213 miles per hour. So apparently the wind is helping, to speed the plane along. It's going a little bit faster than it was on its own. That is the ground, what they call the ground speed. Okay. And now we need to find that angle alpha. Okay, so to do that, we're going to use the law of sines. Because now we have the, this angle over here, and we know the magnitude. Okay, so we can say this is the 16.2, and we're trying to find an angle, so let's go sine alpha over 16.2 equals our magnitude that we just found. That's still in my calculator. So I'll just put 213. I've rounded off, so whoops. I don't want that there. Oops. A long video. Sine 140 over 213. So I'm not sure what type of error I'll get because of the rounding, so we'll see. All right. So sine alpha is going to equal 16.2 sine 140 degrees over 213. We'll put that in our calculator. So I wasn't going to round off. Let's see what happens. I'll do it both ways. 16.2 sine 140. If I use my non-rounded off answer, so divided by, I get about 0.04896 something, and then I have to go inverse sine of that. So alpha would be inverse sine of whatever that number is. So let me do that real quick. This is without rounding off, but I know a lot of times they round off, so I get 2.8. 2.81, the 2.8 degrees. So we'll leave it at that. Now, if I were to actually do the number 213, let's see what we get. So alternate plan here. 16.2 sine 140, and then divide that by, oh, you know what? I don't think it took my number. 16.2 sine 140 divided by 213. So we'll use the rounded off answer and see if it makes a difference. I don't think it's going to, but let's see. Inverse sine of that. No, it's a little bit different, but when we round it off, we still get 2.8 degrees. Okay, so what does that mean that we found? It means we found this little teeny angle right there, 2.8 degrees. We're going to have to add that to find the bearing. I'm running out of colors here, but I need to take the 140 plus that 2.8. So it's going to be what? 142.8 degrees, and it's southeast still, so in that direction. And I think that's all they want, right? The actual bearing. Okay. You could put from the north if you wanted to.